So today I'm going to be doing a problem. It's a proof problem using an inductive argument. It's a bit advanced. I mean, it's not like algebra or something easy, but I think I can try to present it intuitively enough you guys can understand. Hopefully, you might need to understand what an inductive argument entails, but hey, this is my problem. So the problem is, given a triangle that is subdivided into 4 to the n triangles, if I cover one of the tiles, of the subdivision tiles, then I should be able to tile, or to cover the rest of it using tiles that look like this. So basically what this is saying is, I remove one corner, and here I'm going to remove this corner. Then, as long as I have 4 to the n divisions, I should be able to cover the rest of the tiles with shapes that look like these. And obviously, for this first case, by the way, n is, here is 4 to the first power. There's only 4 tiles. But what I'm saying is, obviously I can take this guy and just cover the rest of all these tiles by just putting him there. It's not that difficult for this case. So I can easily cover all the tiles in this case, obviously. So I need, for an inductive argument, I need to prove this for the n plus 1 case. So that's what I'm going to do. So here we have 4 to the first power. So 4 to the n plus 1 here looks like 4 to the second power. So I'll go ahead and draw that. So I have 4 to the second power is equal to 16. So this is the 4 to the n plus 1 is equal to 4 times 4 to the n. And the reason this guy is important actually is because that, oh wait, let me finish drawing him. I forgot a whole bunch of triangles. Okay. The reason that this thing is important here is because it's saying that there's 4 to the n subdivisions in there, and we can find them. So we'll have one of those subdivisions is here, one of those subdivisions is here, one of them is here, and another one is here. So as you can see, there are indeed 1, 2, 3, 4. 1, 2, 3, 4. 4 to the n. There are 4 of these guys inside this guy. And you can see that. So now I'm trying to see if I can tile the entire this guy. So I'll check that. I'll see if I can do that. So the first rule of the game is I have to remove one of the tiles. Okay. So I removed one of the tiles. Now I need to see if I can fill in the rest of them. Well, the long and the short of it is, I can easily complete this proof by cleverly placing my first trapezoidal piece such that it takes out one corner from each of the remaining 4 to the n subdivisions that doesn't already have a corner removed, and by my inductive hypothesis, I can say that it works for 4 to the n case. And then therefore, in our case, 4 to the n plus 1. And what does that look like? Well, where should I place a tile cleverly? I should place it here. You see, if I take out these guys with my tile, it looks like this. I've removed this guy. It's now the case that that each of my 4 to the n subdivisions has one tile removed. And then, as I said previously, by the inductive hypothesis, I can then cover them all, because I already supposed that it works for 4 to the n case. And you can see that here. I just take this shape and I can place it here, here, and here, and of course here, and obviously I cover them all. And that's tonight's problem. Coolio. Stay frosty.